So today we're going to look at inverse trig. Now the notation you're going to see, it's either going to have a little -1 as an exponent, or you'll see the word arc in front of it. So sine to the -1 of x, or arc sine of x, both mean find the inverse of sine. Now when I'm dealing with sine and finding its inverse, I'm going to use the right half of the unit circle. Now, we know it starts at 0, and here would be pi over 6, pi over 4, pi over 3, and then pi over 2. Now, since we're only looking at the right half of the unit circle, I can't continue to rotate counterclockwise because the left half of the unit circle isn't there. So I need to think about starting at 0 and rotating clockwise. Now, if you remember back to last unit, when I rotate clockwise, that gives me my negative radian measures. So instead of 11 pi over 6 being in quadrant 4, it's now going to be negative pi over 6. And then negative pi over 4, negative pi over 3, and then negative pi over 2. When dealing with the inverse of cosine, or arc cosine, we're going to deal with the top half of the unit circle. So these are where my answers are going to come from. The top half of the unit circle, quadrants 1 and 2, that's going to start at 0 and go to pi. So I would have pi over 6, pi over 4, pi over 3, pi over 2, continuing my counterclockwise rotation. 2 pi over 3, 3 pi over 4, 5 pi over 6, and then pi. So, depending on whether or not I'm finding the inverse of sine or the inverse of cosine, depends on which half circle I'm going to look at. So, let's look at some examples here. Number 1 asks me to find the arc sine of -1. So, what I want to ask myself here is, sine of what angle measure is going to give me -1 as my y value, right? Sine is y. So that would put me at the bottom of my unit circle. That would put me right here, right? -1. So the angle measure that would give me a sine value of -1 would be the radian measure negative pi over 2. And that is your answer. So when you think about inverse trig, you want to think about kind of doing the opposite. So it's going to give me the x or the y value, and I need to find the angle measure that goes with that x or y. So let's look at number 2. Cosine. Cosine deals with x, and I'm going to use the top half of the unit circle. So my answer is going to be somewhere between 0 and pi. So cosine of what angle measure has an x value that's positive square root of 3 over 2. So again, looking at my top half of the unit circle, an x value of square root of 3 over 2 would go with pi over 6. So my answer here would be pi over 6. Again, to reiterate what we're doing here, it's giving me the x or the y value and asking me to find what radian measure goes with that x or y. That's all finding the inverse is. Now, number 3 introduces a negative here. So we have the sine inverse of -1/2. So we want to look at that first half circle, right? The one on the left here. And what y value would have -1/2 as its answer? So looking at my unit circle, that would give me negative pi over 6. Again, I don't want to do 11 pi over 6 because I can't do counterclockwise rotation to get to quadrant 4. I have to go clockwise, which makes it negative. Now, we can also do composition of functions involving inverses. The way we're going to handle this, we want to start on the inside of my parentheses. So we'll start with finding sine inverse of the square root of 2 over 2. So sine of what angle gives me a y value of root 2 over 2? So again, looking at the right half of my unit circle, that would give me pi over 4. So that takes care of the inside. Now, I just want to bring down whatever's on the outside. So I want to find the cosine of pi over 4, and that gives me the square root of 2 over 2 again. Now, that just happens to be the case since it's pi over 4 and x and y are the same. Don't fall into the trap of looking at your inverses and thinking things might cancel out. That's just the case because it's pi over 4. Now let's look at number 5. We have the arcsine of the sine of negative 2 pi thirds. So when I look on the inside, this is just a normal trig function. So this is finding an exact value. So I'm going to use the entire unit circle for this. Negative 2 pi thirds. So that's clockwise rotation. And here would be negative pi over 3. Here would be negative 2 pi over 3. So that means I'm in quadrant 3. Pi over 3's have a sine of the square root of 3 over 2. So I'm in quadrant 3, which means sine is negative. So that would be negative root 3 over 2. Okay, so that takes care of the inside. Now, I want to bring down whatever's on the outside. So on the outside, we just have arcsine of negative root 3 over 2. So I want to find the inverse of sine of negative root 3 over 2. So what sine of what angle has a y value that's negative root 3 over 2? So negative means that it's going to put me somewhere down here, right? And root 3 over 2, again, for sine to be root 3 over 2, that goes with my pi over 3's. So inverse of negative root 3 over 2 is going to leave me with negative pi over 3 as my answer. Alright, last one here. We have arcsine of the cosine of 7 pi over 6. So again, start on the inside. That's a normal trig function. So again, I'm going to use the whole unit circle. So when it's a normal trig function, again, we're going to use the whole unit circle. When it's inverse, we're going to figure out which half circle we're using. So whole unit circle, 7 pi over 6, that's going to put me right here in quadrant 3. Cosine of my pi over 6's, that would be square root of 3 over 2 again. I'm in quadrant 3, so cosine's negative. So the inside here would be negative root 3 over 2. Now bring down the outside. So we have arc cosine of negative root 3 over 2. So cosine of what angle is going to give me negative root 3 over 2? So I'm going to look at my cosine half circle here. It's negative, so it's going to put me in quadrant 2. And root 3 over 2 as a cosine, that goes with my pi over 6's again. So the pi over 6 in quadrant 2, that would be this guy right here. So my answer would be 5 pi over 6. Alright, so that's finding the inverse of sine and cosine, but those aren't the only trig functions we have. So let's look at finding the inverses of the other ones. Now the nice thing is we're going to use the same half circles. Your job is just to remember which half circles go with which inverse trig functions. So be vertical half circle. That went with sine inverse. Now, if it goes with sine, it's safe to assume that it's going to also go with its reciprocal. So this half circle also works for cosecant inverse. And it happens to also work for tangent inverse. And just so we have it on this page, I'm going to go ahead and redo this half circle real quick. So we have 0, pi over 6, pi over 4, pi over 3, pi over 2, and then the negatives. Negative pi over 6, negative pi over 4, negative pi over 3, negative pi over 2. So then the horizontal half circle, okay, that goes with cosine inverse. It's reciprocal, so secant inverse, and then it also works for cotangent inverse. And again, I'm just going to fill in this half circle. 0, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi thirds, 3 pi fourths, 5 pi 6, and then pi. So, when dealing with the other 4 trig functions, the first thing we want to identify is which half circle am I using. So, looking at number 7 here, it's asking me to find the secant inverse of negative square root of 2. So, secant means I'm going to use my horizontal half circle, and it's negative, so it's going to put me in quadrant 2. So the easiest way to deal with the reciprocal functions is to kind of change them back into cosine and sine. So secant deals with cosine. Secant is 1 over x. So what we're going to do is take what it's asking us to find, and we're going to put that in for x. So that would be 1 over negative square root of 2. Rationalizing that, I would have negative root 2 over 2. So ultimately what I did was I took the reciprocal part out of it and made it x again. So now it just becomes like what we did on the first 6 problems. Cosine of what angle is going to give me negative root 2 over 2 as an x value. So quadrant 2, square root of 2 over 2 goes with my pi over 4s. So that means my answer is going to be 3 pi over 4. Alright, so let's practice that same thing but with cosecant this time. Cosecant inverse is 1 over y. Sine and cosecant, I'm dealing with my vertical half circle. Now let's take the 2, plug that into my denominator. Now the nice thing when it's not a root, I don't have to rationalize. So what I'm really finding here is the sine of what angle measure is going to give me a y value of 1/2. So looking at my vertical half circle, I'm positive, so I'm in quadrant 1. Y equaling 1/2, that deals with my pi over 6s again. So quadrant 1, my answer here is just going to be pi over 6. Now, tangent and cotangent is a little bit trickier to deal with. But remember I told you all that tangent equaling 1 or negative 1, or cotangent equaling 1 or negative 1, has to go with your pi over 4s. Then it's just determining, based on positive or negative, what quadrant you're in, and that helps you to identify which answer choice you're going to choose. So, first off, tangent deals with my vertical half circle, and it's negative, so that's going to put me in quadrant 4. And again, it's negative 1, so that means it's one of my pi over 4s, so the pi over 4 in quadrant 4 for this half circle gives me the answer negative pi over 4. Cotangent deals with my horizontal half circle. The horizontal half circle negative means I'm going to be in quadrant 2. So the pi over 4 that's in quadrant 2 would be 3 pi over 4. Now, the other way to deal with tangent and cotangent, especially when you don't have 1 or negative 1, because that one's easy, you don't have to do much thinking. You just have to remember tangent, cotangent of 1 or negative 1, that's going to be one of the pi over 4s. Now, when it's not, and it has a radical involved, we want to think about my fraction. So, cotangent is x over y. Square root of 3 as my answer. That means I had to use some combination of 1/2 and square root of 3 over 2. So one of those has to be the x, one of those has to be the y. But we have to identify which is which. And that's where looking at this comes into play. Now if I think about my fraction, right? If I have 1/2 and the square root of 3 over 2, when I divide those two things off, the 2's will cancel out. And I'm left with the square root of 3. In order for that to happen, that means this guy has to be on top. So that way I get root 3 over 2 over 1/2. Those would cancel, and I'm left with the square root of 3. So I want to ask myself, what has an x of square root of 3 over 2 and a y of 1/2? Well, that deals with my pi over 6's. So cotangent deals with my horizontal half circle again. Positive, so I'm in quadrant 1. So my answer choice here, where x is root 3 over 2 and y is 1/2, that would have to be pi over 6. Alright, now looking at composition, you can do that with these 4 trig functions as well. So again, we start on the inside. So this time, the inside is an inverse function, so I have to figure out which half circle I'm using. Cosecant deals with my vertical half circle. So I'm looking at 1 over y. Let's take this and plug it in. That gives me negative 1/2. So sine of what angle gives me negative 1/2? That would be a pi over 6 again. And it's negative, so that's going to be in quadrant 4. So I have negative pi over 6 on the inside. Now we're going to bring down what's on the outside. So sine of negative pi over 6, that leaves me with negative 1/2. And that's it.